Hi, this is to help you with filling in your unit circle in case you don't remember everything or you kind of want to understand some of the reasoning behind how it is created. So before we actually fill in our unit circle, I'm going to review a little bit with you about triangles, and we're going to look at a couple special cases. We'll then translate that to what it looks like on the unit circle, and then actually getting the coordinates on our unit circle. And also talking about sine, cosine, and tangent in regards to our unit circle. Alright, so first thing is let's go ahead and look at these two special triangles. The first one on the left-hand side here is going to be our 45, 90-degree triangle. And we know that this angle here is 45 degrees because obviously all of our degrees have to add up to 180 degrees overall. So we have one side that's given, our hypotenuse, which is a unit of 1. We need to figure out what these two other sides, their length would be with a hypotenuse of 1. We're going to use the Pythagorean theorem. So if you remember this obviously from like geometry or algebra 2 or algebra 1, a squared plus b squared equals c squared. Okay. So let's go ahead and talk about how we would use this to find our two other sides. We know that the c value, our hypotenuse, is 1. So if we plug it into the formula, we'll put it over there. These two sides are going to be the same length because of the right triangle, and they're opposite the same degree measure. So I'm just going to call them both a. So it's going to be a squared and a squared, okay? Because basically a equals b. All right, these two other sides equal each other. So if you work through it, divide both sides by 2. So you get a squared equals 1/2. We're going to take the square root. We will consider only the positive square root since we are dealing with the side of a triangle. So a equals the square root of 1 is 1. Square root of 2 we're going to leave as so. We need to rationalize our denominator, so I'm going to go ahead and do that by multiplying the top and bottom by the square root of 2. So a equals the square root of 2 over 2. And that means that both these sides of the triangle are going to be the square root of 2 over 2. Oops, sorry. So we have the square root of 2 over 2, and this side here is also the square root of 2 over 2. Okay, so it'll become important when we look at the triangles later on our unit circle. All right, let's go over to the other triangle here. There's actually, it's kind of like a triangle within a triangle. You'll see that this whole triangle here along the dotted line as well is an equilateral triangle. Okay, they all have equal sides. We are going to end up taking half of this equilateral triangle. So it would be 60, half of 60 here would be 30 degrees and 90. Okay. We can figure out basically the length of A. Okay, is going to be half that base of our equilateral triangle. Okay, so A is going to equal 1/2 if originally all the sides of our equilateral triangle were 1. Okay. Then we're going to go ahead and use the Pythagorean theorem again. And we're going to figure out our missing side B. Okay, so I'm going to plug in what I know, and I'm going to end up solving for B. So A is 1/2. Alright, so 1/2 squared is 1/4. And 1 squared is 1. I'm going to make it 4 over 4, so I have a common denominator. I'm going to subtract 1/4 from both sides, so I get 3/4. I'm going to take the square root, and what I end up with is b equals the square root of 3 over 2. Oh, sorry about that. Let me move that up a little bit. Okay. So I'm going to go ahead and fill in up here and say b is the square root of 3 over 2. Okay, so now that we have those couple measurements down, we're going to go ahead and move these triangles onto the unit circle. Alright, so if you want to go ahead and move to the bottom part of your paper, and we're going to call this triangle down here is going to be our 45, 45, 90. Okay? So you know, if we were to be finding this coordinate on the x and y axes, your x value would be how much you go over. Remember from above, that was the square root of 2 over 2, comma, and how much you go up. The length of that side was also the square root of 2 over 2. In a moment, you'll see how this translates onto the unit circle. All right, I'm going to move over to the other triangle on the unit circle, and keep in mind that the radius of this unit circle is 1. Okay, so it's still the same from before. So this triangle that we were just looking at that radius is 1. Alright, so let's go over here. We're going to take the same triangle, so it's 60 degrees, 90, and 30. It's still 1 up there. Remember how I talked about we have this ordered pair. So how much we go across, our x value is going to be 1/2. And how much we go up is going to be the square root of 3 over 2. So I'm just taking those triangles from above and putting them onto the unit circle. Hopefully you remember this from pre-calc, but if not, it says the ordered pair for each point in the unit circle is, do you remember what the x value represents? Take a moment so you can kind of remember it. It's going to be our cosine theta, and the y represent is sine theta. Okay? And if you're thinking about tangent theta, remember how it is basically like your slope. It's your rise over your run, so y over x, which is the same thing as sine theta over cosine theta. Alright, I'm going to help you fill out the first quadrant for your unit circle, talk about some of the patterns, and then let you try filling in the rest on your own, and I'll put up a finished unit circle for you to check your work with. Alright, so if you want to go ahead and flip over to the other side. So as we go about this unit circle, you're going to want to keep in mind that I'll be listing the ordered pair, so x comma y, which remember again is kind of like cosine theta, sine theta, and then I'll be also listing the slope, which is considered our tangent theta. Okay. Alright, so I'll also do it in both radian and degrees. You'll need to know both of them. Right here, before we've moved anywhere, is 0 degrees, or 0 radians. Okay, we're going to go up by 30, so up here it is going to be 30 degrees. And the corresponding radian measure is pi over 6. And remember, just like there's 360 degrees in the circle, it is 2 pi if we are in radians. So we're just using equivalent fractions of 2 pi as we go around our unit circle. Okay. Alright, so let's keep going up here. I'm going to go by the 30s first because it'll make a little bit more sense. So if we go up another 30, be up to 60 degrees. Okay. And basically if we add another pi over 6, it gets us to 2 pi over 6. And 2 pi over 6 will reduce down to pi over 3. Okay. We go another 30, it gets us to 90 degrees. Think about pi over 6, 2 pi over 6, 3 pi over 6 reduces down to pi over 2. Okay. Right here is going to be half of 90 degrees. Okay, you can hopefully kind of see that, which is our 45 degrees, which corresponds to pi over 4. Okay, if you think about it, you have pi over 4 plus another 1/4 would give you 2 pi over 4, which also reduces down to pi over 2. Okay. Alright, so let's go ahead and fill out the rest of this together. You can see here your x value is 1 and your y value is 0. So if you are finding tangent, it's going to be y over x, so 0 over 1, which just equals 0. So let's go up to the 45 and the pi over 4 first. That was, if you go back to the investigation that you did on the other side, remember this ordered pair is the square root of 2 over 2, square root of 2 over 2. Okay. Remember tangent is y over x, so y over x, it's the same thing over each other, so it just equals 1. Okay. Let's go up to the 60 degrees. Remember that ordered pair from our unit circle investigation was 1/2, comma, square root of 3 over 2. Okay, and when you kind of think about this, remember this is the x value and this is the y value again. If you're looking at your unit circle, you can kind of see that the x value down here is going to be the shorter or smaller length than what your actual y value is. Okay, so 1/2 is less than the square root of 3 over 2. So it's kind of a way to keep it in your brain. Okay, so tangent is going to be square root of 3 over 2, and then it's divided by x. So x is 1/2. So if you simplify this, you get the square root of 3 over 2. You want to multiply that by the reciprocal. So you're going to get radical 3 for tangent of 6 degrees, or pi over 3. Alright, if we go back down here to 30 degrees, our triangle has just been flipped around. So we're just going to flip these ordered pairs. So it's the square root of 3 over 2, comma 1/2. And we're going to need to find out what tangent is again. So it's y, which is 1/2, divided by x, so the square root of 3 over 2. When we divide, we're really just multiplying by the reciprocal. So we end up with 1 radical 3. We need to rationalize our denominator. So we're going to end up with, oops, sorry about that. Rationalize our denominator. End up with the square root of 3 over 3. So I'll fill that in here. Okay, so there is quadrant 1. You'll notice that in our first quadrant, so I'm going to go up here. Actually, let's fill this in as well. At 90 degrees, we know that our x value is 0, our y value is 1. 1 over 0 gives us undefined for tangent. Okay, so in quadrant 1, we know that x is positive and y is positive also. Okay, x and y are both positive. If you go into quadrant 2, you can hopefully see from your axes that x is negative. Okay, and y is positive. Okay, so it's going to be the same ordered pairs, except each x value will be negative and y is positive. And that means that tangent is negative. Oops, sorry about that. Let me move that down a little bit. There we go. X is negative, y is positive, and tangent is negative. Go down into quadrant 3. Okay, x is negative, y is negative also. So that means that tangent is going to be positive. Okay, and then in your last quadrant, you can see that x is positive, y is negative. So quadrant 4, x is positive, y is negative, and that means tangent is going to be negative. Right, so I want you to take a moment, see if you can fill in the rest of the unit circle. I'm going to pause it right here, and then we can go ahead and look at what your finished unit circle should be. Alright, so for quadrant 2, that's what it should look like. You can pause again if you want to kind of check your work. For quadrant 3, this is what quadrant 3 should look like. Okay, check your work, make sure it's correct. And for quadrant 4, this should be what it looks like. Okay? Alright, if you have more questions, feel free to ask me in class or come after school.